Hello everyone, welcome to my channel. Today we are going to discuss about the integration by substitution method. Now here generally there are three methods to find the integral of any function. The first method is the integration by substitution. Second method is the integration by parts, and the third method is integration by partial fraction. So we are going to discuss about the first one, which is integration by substitution. Now, integration by substitution is a powerful technique in calculus that allows us to simplify this complex integral by introducing a new variable. Okay, so this method is useful whenever you are dealing with the composite function. Composite function is a function of another function, and also when you are dealing with the trigonometric functions and other complicated forms. By selecting an appropriate substitution, we transform this complicated integral into the easier form, which will be easier to evaluate. So now we are going to solve some of the problems that will help you to understand that how we can use this substitution and find the integration of that part. Thank you. Okay, now let's just study the examples in which we are going to see that how you can use the substitution and do the integration. So the first example is I is equal to integration sine inverse of x to the power 3 over 2, that is 3 by 2, the whole upon under root of 1 minus x square dx. Okay, now to choose the appropriate substitution, first of all you must remember all the formulas of the differentiation. Okay, so if you know the formula of the differentiation, you will be easily be able to find the function that you can use for the substitution. Okay, and whatever function you choose, make sure the derivative of that function is already present in the question. Like here, if I put sine inverse of x, if I decide to put sine inverse of x is equal to t, so when we differentiate this, it gives you 1 upon square root of 1 minus x square dx equals to dt. Okay, now if you can see here, we already have this part, that is we have in the numerator as dx and in the denominator under root of 1 minus x square. So this whole can be replaced with this single term, that is dt. So this becomes integration and this can be replaced with dt. Now the sine inverse is replaced with a variable t, another variable t, and we have the power as 3 by 2. Now this can only possible if you are comfortable with the formulas of the differentiation, and also you should have the ability to find that function in which the derivative is already present. Okay, so here we can apply the power formula of the integration, which is nothing but t to the power 3 by 2 plus 1 upon 3 by 2 plus 1 plus c. Okay, so what we get here is 3 by 2 plus 1 is nothing but 5 by 2 upon 5 by 2 plus c. So that gives you 2 over 5 t to the power 5 by 2 plus c. We can resubstitute the variable, that is 2 by 5 sine inverse of x to the power 5 by 2. So this is the final answer of this integration. Okay, now we'll move on to the next one, which is the second one. Okay, so the second problem is I is equal to integration sine raised to 4x multiplied by cos cube x dx. Okay, so here we have the two trigonometric term, sine as well as the cos. The sine is having a power of 4 and cos is having a power of 3. Okay, now what we will do, we'll keep this sign as it is, but we will write in different form. Okay, so if you want this, you can write this as it is, and we can split this as cos square x into cos x. Okay, After that we'll keep this again as it is. We'll change this cos square into sine, that is 1 minus sine square theta, like that, if you remember the trigonometric formula. Okay, and this is cos x dx. Now what I have done is we have completed, or we have converted this cos into in the terms of sine while keeping one cos aside. Now what is the motive over here is we will substitute sin x as t, because the derivative of sin x is nothing but cos x dx is equal to dt. Always you have to write the derivative with the dx part. Okay, so here the cos x dx is present, that will be replaced with dt. Okay, so this I now will be nothing but dt, and the sign is replaced with the variable t, so that becomes t to the power 4, and this becomes 1 minus t square. Okay, now what we can do, we can multiply this inside, that gives you t to the power 4 minus t to the power 6 dt. You can apply this power formula on both of this, that gives you t to the power 5 upon 5 minus t to the power 7 upon 7 plus c. We can resubstitute this, that is nothing but sine to the power 5 x upon 5 minus sine to the power 7 x upon 7 plus c. Okay, so this is how you can work out. When you solve more and more problems based on the substitution, you will be able to get more and more ideas how we can solve this. Okay, now let's just move on to the next part, that is example 3, integration square root of tan x the whole upon sin x into cos x. Now here we have three trigonometric terms. If you can see, we have three trigonometric terms: tan, sin, cos. Okay, so what we can do, we will do the division in the numerator as well as the denominator, but by which term? That will be by cos square. Okay, so I'll divide the numerator by cos square x as well as the denominator by cos square x. Just check this. Okay, dx. Then what will happen here is, in the numerator we can write 1 upon cos square as sec square, square root of tan x. Okay, and in the denominator one cos will get cancelled and one cos will left, that sin upon cos will give you tan dx. Okay, now put tan x is equal to t. Now we have chosen the tan x because the derivative of tan x sec square x is already present, so we will just write derivative of tan x is sec square x dx equals to dt. Okay, so here I will be equal to, now sec square x dx, this sec square x and dx will be replaced with dt, so I'll write dt over here. Now we left with under root of tan x upon tan x, so that will be root of t upon t. Okay, now I is equal to root of t upon t, that gives you 1 upon root of t dt. Okay, so root of t is nothing but power half. When we take it in the numerator, that becomes negative half. So we can apply the power formula, negative half plus 1 upon negative half plus 1 plus c. So here we got the value as negative half plus 1 is half, and this will be half plus c. So this is 2 root of t plus c. We can resubstitute this t as well, that is under root of tan x plus c. So this is how we have solved this question. Now this is a complicated one, but you have to work out more and more. Okay, so as to you get the idea. Okay, now we'll move on to the next question. Question number 4, fourth example, that is I is equal to integration x square upon square root of 9 minus x to the power 6. Now just look at it. The power in the numerator as well as in the denominator is different, because in the numerator we have the power as 2 and the denominator we have the power as 6. So what we will do, we'll convert the same power in the denominator what we have in the numerator. Okay, so we'll write x square under root of 9 minus, and what we can do, we'll write x cube the whole to the power 2. Now why I have chosen x cube inside and the 2 outside, I'll tell you that. First of all, just see here that we have got x cube inside. Okay, so when you substitute x cube as t, so when you take the derivative, this become 3x square dx equals to dt. Okay, so that is nothing but x square dx is equal to 1 upon 3 dt. That is why I have chosen this. Okay, so I'll write it over here. So let's just write this here. Put x cube is equal to t. So the derivative of x cube is 3x square dx equals to dt. So x square dx equals to 1 by 3 dt. Okay, so here becomes x square dx will be replaced with 1 by 3 dt. So I'll write 1 by 3 dt here, integration 1 upon square root of 9 minus, and x cube will be replaced with t, and we have the power 2 outside, so here will be 2. Okay, so now we have got 1 by 3 you can take outside. This will be square root of 9 minus t square dt. Now what the other form of this will be square root of 9 can be written as 3 square minus t square. Okay, now we are going to use the special integral formula. I'll write it over here in the note section. Integration of 1 upon square root of a square minus x square dx. Okay, a stands for the constant value. Okay, so that is nothing but sine inverse of x upon a plus c. So here the value of a is 3, so I'll write it here as 1 upon 3 sine inverse of t upon 3 plus c by applying the special integral formula. Okay, now we'll resubstitute this. This is 1 by 3 sine inverse of x cube upon 3 plus c. So this is how you have got the value of this integral. Okay, now we'll move on to the next question. Question 5. I is equal to 1 upon, this is a bigger term in the denominator, x log x, then log of log x dx. Okay, now we have these three terms, x, then log x and log of log x. Okay, so what I'll substitute here is the most complicated form, which is log of log x as t. So when you take the derivative, this becomes 1 upon log x, and the derivative of log x is 1 upon x dx equals to dt. Now I have this 1 upon x log x in the question itself. You can check it out here. 1 upon x log x along with dx. Okay, so what I can do, I is equal to, that will be replaced with dt, and this becomes 1 upon t. The only thing we are left with this term, so that is nothing but t. Now 1 upon t, the integration of 1 upon t is nothing but log of mod of t plus c. So we can resubstitute this part, which is log of log x plus c. Okay, now sometimes it will look more complicated, but it is just a simple one. You just have to identify the proper function that you can use for the substitution. Okay, now we'll move on to the next question, which is question 6. So I is equal to cos raised to 8 x and cot x integration dx. Okay, right. So now what we'll do here is we'll open this cot x. We'll keep this cos x as it is, and cot x is nothing but what? Cos upon sine dx. Then we'll multiply and divide it. Now cos raised to 8 and cos x becomes cos raised to 9x. Okay, we have the numerator in as sin x. We'll multiply and divide by sin x. Okay, so that becomes cos raised to 9x into sin x upon sin square x dx. But in the denominator, the sin square can be written as 1 minus cos square, and here we are having cos raised to 9x sin x dx. Now what I have done, I have converted this into two terms, that is sin as well as the cos. The first term you can see in the numerator as well as in the denominator I have the cos, and the derivative of the cos is sin x. That is why I have purposely multiplied in the numerator as well as the denominator with the sin x. Okay, so we'll substitute this. Cos x is equals to t, so that gives you the derivative of cos x is minus sin x dx equals to dt, but we don't have the minus sign, so we'll shift the minus side on the other side. That gives you minus of dt. Okay, so here that will be I is equal to integration. Now sin x dx will be replaced with minus of dt. Okay, and this gives you t to the power 9 upon 1 minus t square. Okay, what we'll do here, we'll take this minus and we'll give it in the denominator, so that gives you t to the power 9 t square minus 1 dt. Okay, so in the numerator we have t to the power 9, which is greater than the power in the denominator, and in the denominator we have t square minus 1, so we'll have to divide this. Okay, so I'll take a new page and we'll divide this. You have to show this working. So this is t square minus 1 and this is t to the power 9. Okay, yeah. So we have this t square, we have to multiply it with t to the power 7. So t square multiplied by t to the power 7 gives you t to the power 9, and minus 1 multiplied with t to the power 7 is minus t to the power 7. Now the first term will be subtracted, second term will be plus, because we have to change the sign as we are doing the subtraction. So the first part will be get cancelled and we are left with t to the power 7 plus t to the power 7. Now again we are having t to the power 2, we now have to get the t to the power 7, so we'll multiply this with t to the power 5. So t to the power 5 multiplied with t to the power 2 gives you t to the power 7, and minus 1 multiplied with t to the power 5 is minus t to the power 5. Again we'll change this sign and we'll reverse this. So this gives you again t to the power 5. Now since t to the power 5 is greater than t to the power 2, so we'll multiply this with t to the power 3. So t to the power 2 multiplied with t to the power 3 gives you t to the power 5, and minus 1 multiplied with t to the power 3 is minus t to the power 3. So this will be minus and this will be plus again, that gives you t to the power 3. Now we have t square, we'll multiply this with t, so t square multiplied with t gives you t cube, and minus 1 multiplied with t gives you minus t. This is minus, this is plus. So overall we left with t. Okay. Now what we have in the numerator here, this is your quotient. Okay, this is your remainder, and this is what we call as dividend, and this is divisor. So we'll use the basic formula, which is nothing but dividend is equal to divisor into quotient plus remainder. Okay, now we'll divide this whole equation with divisor, so that becomes dividend upon divisor is equal to, the divisor will get cancelled, so we left with quotient plus remainder upon divisor. Now what we have in the dividend, that is t to the power 9, and divisor is t square minus 1 is equal to, what is your quotient? T to the power 7, t to the power 5, t to the power 3 and t, plus what we have in the remainder, which is t upon divisor is t square minus 1. Okay, so overall we can replace your question with this whole term and will integrate individually. Okay, so we'll take the new page. I can change your question now, which is nothing but t to the power 7 plus t to the power 5 plus t to the power 3 plus t plus t upon t square minus 1 dt, the whole dt. So we'll integrate this individually. Now first will be integration of t to the power 7, then t to the power 5, then t to the power 3, then t to t dt, and this will be t upon t square minus 1 dt. Okay, now we can use for 1, 2, 3, 4, we can use the power formula for all of this, but for the last term, this one, we have to use some special property of the integration. I'll tell you that special property. What is this special property? So just note it over here. I'll write it down at the bottom. Integration, whenever you have the function, okay, in the denominator and you have the derivative of that function in the numerator, so the answer becomes log of f of x, the log of original function. Just remember, the derivative is in the numerator and original function is in the denominator. So if you look at this, you have the original function in the in the denominator, and if you take the derivative of denominator, you can take the derivative. This is nothing but 2t minus 0, which is 2t. Okay, so in the numerator we have only t, so what we'll do, we'll multiply and divide with 2. Okay, so that it matches this property. Okay, right, so I'll just rub this out and we'll multiply and divide this by 2. Okay, so now this becomes t to the power 8 upon 8, t to the power 6 upon 6, we are applying the power formula, t to the power 4 upon 4, t to the power 2 upon 2, and this will be log of t square minus 1, the original function that we have in the denominator, plus c, and now we can resubstitute with cos. So this becomes cos raised to 8 upon 8 cos raised to 6 upon 6, and cos raised to 4 upon 4, cos raised to 2 upon 2, and this will be cos square x minus 1 plus c. Okay, so this is how you can solve your integration, the complicated integration, with the help of the substitution. We have some more example based on the substitution, but I'll cover this in the later videos. Thank you for watching this video. Have a great day.